Hello, Python enthusiasts. Welcome back to our channel. Today, we're delving into the fundamental concept of typecasting in Python. Typecasting, also known as type conversion, is the process of converting the data type of a variable into another data type. In Python, we leverage built-in functions like int, float, str, and bool for these conversions. Typecasting ensures smooth operation compatibility, efficient data processing, and robust code. Let's explore this vital topic together. In this code snippet, without typecasting, we are prompting the user to input two numbers. Whatever the user types in response, whether it's a number or any other string, it will be stored as a string. The input function returns a string, even if the user enters a numerical value. Therefore, num1 and num2 will both be strings. When you try to add them together using the plus operator, Python concatenates the strings instead of performing addition. This can lead to unexpected results, especially if the user intends to add numerical values. To correct this error, we can use typecasting to convert the input strings to integers before performing addition. In this corrected version, we use the int function to convert the input strings to integers before adding them together. Now, the addition operation will perform numerical addition instead of string concatenation, yielding the correct result. Python doesn't stop there. It also performs implicit typecasting, or automatic conversion, without any explicit function calls. For example, when we add an integer and a float together, Python seamlessly converts the integer to a float to perform the addition. Now, while typecasting in Python is indeed powerful, it's essential to follow some best practices to avoid potential pitfalls. Understanding data types, using explicit casting cautiously, and testing edge cases are key practices to keep in mind. In conclusion, mastering typecasting in Python is indispensable for developers. It ensures seamless handling and manipulation of different data types, leading to robust, error-free code. So, keep practicing, keep exploring, and keep coding. Thanks for tuning in. If you found this tutorial helpful, don't forget to like, share, and subscribe for more Python tutorials. Happy coding!